My name is Chris Lee. My student number is S224817878, and this is the Arduino control using sensors task. Now for this task, in terms of configuration, we have our soil moisture sensor here, and we have 3 jumper cables, and we have our standard microcontroller that we've been using for all of our tasks. For the configuration of the sensor, our SIG terminal on the back here connects to A0 on the analog channel. This is how we're going to get our analog readings when we're assessing the moisture content of the soil, or the sample soil rather. White is connected to ground, and VCC, which is the purple jumper cable, is connected to pin 7, and this is how we're going to send power to the sensor. So we'll either be able to set that to low or high if we want the sensor to be on or off. In terms of the functionality of the sensor, this is a resistive sensor, so we're going to be measuring the resistance, or the conductivity rather, of the sample soil that we have here. So I have this end is dry and this end is wet, or damp rather. Now, for soil with a sort of high moisture content, the resistance is going to be low, so it's going to be very conductive. When it's more conductive, we're going to receive significantly higher analog outputs. When the probes are in drier soil, the resistance is going to be rather high, and that's going to return low analog readings. We default to 0 here when the resistance is rather high. And just as like a proof of concept later, I'll test it with my fingers just to show that it is measuring high resistance sort of environments, because I don't like the base reading of 0, but that's how they sort of set it up in the documentation, so that's what I've opted to use. Now, most of the action for this task sort of takes place down here in the serial monitor. So I'll go over some of the code and we'll sort of work to understand what's happening here. This is not my code. I've taken this from the SparkFun documentation page, but we'll walk through it anyway just so we know. We start with a number of variable declarations. The integer variable val is going to temporarily store our analog readings. Soil pin here has a value of A0, and this is assigning the analog pin A0 as the connection between the sensor's SIG terminal and the Arduino. And then digital 7, which we had as our purple cable to the VCC on the back of the sensor, is going to be used to provide power. And so we'll either be able to set that as low or high, depending on whether or not we want it on or off. Now, I've opted for that configuration there as opposed to just providing it with constant 5 volts because the documentation was talking about the long-term effects of corrosion. So this sensor is intended to be planted in soil for a long period of time, and having constant power to it speeds up the corrosion process. That's a little bit outside of the scope of this task, but I followed that proof of concept anyway. For our setup function, we're opening serial communication at 9600 bits per second. So that's how we're going to view the data down in the serial monitor. We're going to set pin 7 to output, and this just means that we're going to be sending voltage and we're not going to be reading. The initial state will be low, so it's going to be off. In our main loop, we're printing to the console, and we're calling the read soil method just here. And that's just going to give us the current moisture value that our sensor is reading. A higher moisture content, is going to be a higher analog output, and a lower one is going to be just returning that base of 0 that we were sort of talking about. There's a little delay as well between each of these prints. The read soil method itself down here temporarily sets the pin 7 to high, so that's turning it on. We're sending power. There's a very brief delay, and then we're taking the value, we're reading it, and we're going to print it out, and then we're going to set pin 7 to low again, so that's going to turn it off. For our outputs themselves, just so you can see, first I'm going to place this in some damp soil, so we need both probes to be in the soil there, and you can see that we've got readings that are somewhere from low to the sort of high 800s. Now if I take that off, turn that around and put that into the dry soil with both probes in there as well, again, we're getting our base of 0. So we have rather high conductivity, high resistance, in the dry soil. As a sort of proof of concept here, if we were to place the back of our finger on both probes, we can see that my finger has some moisture content, but it's rather high resistance there, so we're getting low analog readings. And then if I use the front of my fingers, which will be more moist, we're going to get significantly higher readings. Thank you.